Everyone, my name's Ali and this is Ivan, and today we're going to be talking to you about the Google Drive API. The new Google Drive API was launched at I/O, and we're going to take you right down under the water to see all the beautiful things we can find in this API. So this year we launched Google Drive. Very proud of that. And with Google Drive, which is our cloud storage solution, allows you to store files in a safe place, allows you to access them anywhere, and brings to you the collaborative features of Google Docs so you can use them on your files in Google Drive. And with that, we launched the Google Drive SDK. This SDK allows you to put your application in front of all of our users. So if they like your application, they can install it, they can use it in Google Drive. And that very much enhances our product, but at the same time allows you to put your product in front of all these people. The other part of this is we've tried to make this API as easy to use as possible, as effortless to use as possible. So you get all the features of Google Drive, but you get them programmatically, and you can use them in your applications. So what is the API? How does the API relate to the SDK? The API is part of the SDK that is responsible for making programmatic calls against Google Drive. The other bits are little user interface snippets and that kind of thing, and you may have heard of them in the other talks we've had. So programmatically manage a user's Google Drive. Whatever you can do with Google Drive, you can do with the Google Drive API. We're going to talk a few of those things. Well, the first one is uploading files. That's the main use case. Of course, you have to get your files somehow into Google Drive. We allow you to organize your files into folders. Again, you can do that in Drive, but you can do that programmatically using the API. You can search for files. All the powerful search features of Google Drive come to you from the API. Once your files are in, you should be able to download them. We give you a list of changes. That means a sequential list of all the things that have changed in a user's Google Drive. There is a revision history, so much like a version control system, we allow you to manage these revisions programmatically. There is full sharing support, one of our favorite features, sharing and collaboration. You can perform all of this sharing programmatically on behalf of a user. We have some user information bits that we think that's very useful for applications that want to personalize themselves. For example, displaying an image of the user in the top right-hand corner or displaying their email address, just so the user knows exactly that your application knows who they are. And then we've got these two really cool features of processing files when you upload them. And they are OCR and translation. Now, OCR is optical character recognition. I'm sure you all know. And that allows us to extract text from non-textual files. So if you have a PDF, you have an image that has textual content, that can be extracted by the API when you upload or update files. Similarly, translation, that's human language translation. If you have a document in French and you'd like it to appear in your Drive translated into English or any other language, you specify the query parameters, and that happens there. So you can see here that this is a very large feature set for an API. There's a lot of things. Important for me to tell you now is that your integrations with the API can be small integrations. You can just have a bit of sharing. Or they can be large integrations. You can have uploads, downloads, file management. It really depends on your type of application. Some applications are more suited than others, but really any application that involves files of some kind, they don't even have to be actual files, something that looks like a file, is a good fit to have a Google Drive API integration. Some of you have used the Documents List API, one of the three previous versions, and really the Drive API aims to replace the Documents List API. It should provide all the functionality. The point about this is the Documents List API is something that's been around for a long time, and it's a mature, well-tested piece of software. A lot of people use it, so we've really taken this infrastructure and we've upgraded it. We've tried to make it easier to use, and part of that is by using the latest and greatest Google API technologies, which gives you really good client libraries, which gives you really excellent documentation. And the final thing we've done is we've tried to improve some of the things we didn't really like about the Documents List API. And one of them is the security scoping model, which I'll talk about now. In the Documents List API, you used to have to, the user used to have to grant access to their complete drive. So you couldn't just say, I want this application to access just this type of file or just these few files. You have to give access to everything. Now that can be a bit of a nightmare. Users traditionally don't really read those warnings when they say they're about to access the whole drive. But people who do care are domain administrators, for example. You don't want corporate documents to be in the hand of third-party applications if you can help it. You can have private applications and private documents in your drive, for example, tax returns, that kind of thing, that you don't want people to have. And so for that reason, we've added different scoping levels to try and improve this. Of course, we still provide the full scope, which allows an application to have full access to your drive. This is very useful for some use cases. For example, if you want to back up an entire user's drive, you need that. But we've added these other scopes, two read-only scopes, one which allows downloading and one which doesn't allow downloading, and then what we call the per app, per file scope that is very unique to this API. This scope allows an application to access only files that have been specifically and explicitly allowed by the user. So if a user says, I want your application to access just this file, your application will access it, but will not be able to access other files. And we think this is very, very unique and a great feature, because it means you don't have to provide access to your whole drive. And lastly, we have the anonymous scope, and that is the scope you get given if you're not a logged-in user at the time, useful for things like public sharing. What is the API itself? Well, it's a standard web-based API. We use JSON, we use HTTPS, and OAuth 2.0 is the recommended authorization method. What does that mean? Well, really it means you can use almost whatever you like to access the API. Any programming language that can make HTTPS calls, any programming language that can pass JSON, you can use. But of course, we would recommend you use one of our client libraries, and we have a number, and they're there. There are others as well. If your favorite language isn't on there, I recommend you write your own API client and get back to us, because it's really much more fun than making direct HTTP calls. So what is the data model? Well, Google Drive obviously is based around files. And when I say it's based around files, everything in Google Drive is a file. We've already spoken about folders, but in fact, folders are files too. How does that work? Well, folders have a specific MIME type, and that's the MIME type we look at to see, is this a file or a folder? This is really nice. We think this is really nice because it allows you to write one code path to handle files and folders, because they're mostly the same thing. They have titles, they have descriptions, and we'll see exactly how they look. But it means you don't really have to special case folders, which we think is really useful. So what is in a file? Well, a file has two components. All files have metadata. Now, the metadata for a file involves its title, its description, the MIME type, those kind of things that are tagged, and we'll see how that looks. Some files have binary data. Now, the astute people in the audience will know an example of a file that has no binary data, and that is a folder. Of course, folders don't have any binary data associated with them, but most files do. So you have an image, it has the title, the description, those kind of things, and then there's the binary data associated with that image. Other kinds of files that don't have binary data, of course, are the Google Docs types of files that are actually more like a shortcut. This entire hierarchy is built up into the top-level folder, which we call the root folder, and that has an alias that you can access, but again, that is just a file as well. It's slightly special, but it's just a file. So you have Drive, root folder, folders amongst that, and then files underneath those. What does a file actually look like? Well, this is the representation that comes back to you when you make API calls. And I just want to point out a couple of fields here. The first one is the ID. That is a consistent ID that will be the ID of that file for the lifetime of that file. So you can store that in your database, and you can use it to fetch the file at a later date. Other important things, there's the title, the MIME type, as I said. If you look there, that is the MIME type for a spreadsheet file. There are other things, labels, which are Boolean attributes, for example, trashed or hidden. And then there's some dates, which can be useful, some links, some permission information, and other stuff there. I've snipped out quite a bit of stuff, but if you've used any JSON API, this is the kind of thing you can expect. The important one, the ID. Remember, you can store that and use it at a later date. So great, you've seen a bunch of JSON, but why does it matter to you? Well, we've thought of a use case. As I've said before, you can use this API a lot in your application, or you can use it a little bit in your application. Now, we wanted an application that used it a lot. And if you can imagine a photo album application, so you have a bunch of photos and you want to store them in your Google Drive, and you want an application to be able to manage these. Conveniently, the feature set that's required by this application is the exact feature set that Google Drive has. You want to upload the images, you want to download them, you want to organize them, you want to be able to search for them, you want to be able to share them. And we're going to go through each of these in detail, and Ivan's going to show you how to do them. But before we start, Ivan, I just want to ask you a question. Why do spicy peppers like Upload so much?
I have no idea.
No idea? You want to try?
I completely blank.
Really? Nothing? So they can get jalapeno drive. No?
I don't get it. Sorry.
Jalap in your drive? Jalapeno?
I
Tough crowd. Let's talk
Yeah,
about uploads. There are 3 types of ways of uploading files to Google Drive. We provide these 3 different mechanisms for different use cases. Fortunately, the client libraries handle all of it for you, all of the logic for you. So really, it's just a matter of specifying which type you want. But it's worth knowing what they are and how they work so you can choose the appropriate one for yourself. Every time you upload a file to Google Drive, you can specify what kind of processing you would like on it. And I've mentioned OCR. You just add these parameters, and your file will be OCR'd. Again, converting to Google Docs. Now, people who have used the Documents List API know that this is a place where we've moved away. Because the previous default for Documents List API was convert equals true. Now, we don't convert files unless you explicitly ask us to do. And the third one is translation, which I've mentioned. So adding these parameters would translate a French document to an English document. The next bit of processing we do always on files that are uploaded that they can be is Google Goggles integration. Now, those of you who've used Google Goggles know that it's pretty amazing. I love it because it's something I always show my family, and they get to realize how amazing Google is. Here's an example. This is actually a photo that Ivan took while he was on a working holiday? Working holiday?
Yeah,
Working holiday in Australia, we'll call it that. Now, he took that photo. Now, when that's uploaded to Google Drive, you may recognize it, this rock formation. When that's uploaded to Google Drive, that is indexed by the Google Goggles backend, and we know what that is. So if you search Google Drive, and again, if you search using the API, searching for any of these 3 terms, whether it be Three Sisters, Katoomba, or Australia, will show this image in the search results. Now, we think that's pretty cool because there's no metadata, there's no file name, it doesn't use that, it actually uses the image itself. And this is a feature you get for free with the Drive API. So back to uploads. The first type is the simple upload. Now, a simple upload is where you would just want to upload a single file, okay? And you see there are some limits there. The first one is you have a 2 megabyte size limit. Now, that's pretty good for small files, but there aren't really any images these days that you take with your camera that can fit in 2 megabytes. The other limitation is that you can't specify metadata. Okay? Why is it simple? Well, it's just a post request with the correct content type, and you send the binary data. The differentiator here is you setting the upload type parameter. And when the upload type parameter is set to media, then we know that that's a simple upload. And you'll see this upload type parameter is how the client libraries choose how to do the upload. So you get a 201 created response and an echo of the data you sent. So that's fine if you don't need metadata and you have files less than 2 megabytes. If you have bigger files, you can use the multipart upload. Now that is a my multipart request, this time with the upload type set to multipart, and you send in the first part of the multipart, you send the JSON, in this case, title, funny photo. That's the metadata. You can put any metadata you want. And in the second part, you send the binary data. So this is great. The file size limit is 10 gigabytes. So you can really send as much as you like there, and whatever metadata you want. There is one major problem here, and that is, what do we do in the case of failure? We don't expect our API to fail. We obviously don't expect your excellent applications to fail. But what could fail is the network connection. So if you're uploading not even a 10 gigabyte file, say you're uploading a 1 gigabyte file, and 3/4 of the way through it, the network connection dies, really you have to upload that again. And for that reason, we provide the next mechanism, the third, which is the resumable upload mechanism. So how does that work? Well, this is based around a session. You will have a minimum of 2 requests. The first request kicks it all off. So you initiate that, and you send the metadata. Once you've sent the metadata, you get a response back, which contains a URL for which we expect you to send the remainder of the data. And once you've sent the remainder of the data, then you get your 201 response back, and that's that. Okay? You may think, well, what's the point in that? I've just done 2 requests when I could have done 1 with the multipart. Well, the beauty of it is, in a situation of failure, when the network dies, you can ask the API, how much have I already uploaded? Exactly how many bytes have I uploaded? And when you make that request, if it's not a completed file, you get a 308 resume incomplete response, which contains information on where to restart. So you can restart the upload only from where you left off, and you upload the remainder of the file. Okay? What does it look like in HTTP terms? Well, this is the initiation of the session. You do a post, again, receive. This is the upload type of resumable, and you just send the metadata. We do ask you to add these 2 extra headers, the XUpload content type and the XUpload content length, that specify the size and the content type of the file you are going to be sending in the remainder of the session. This time you'll get a 200 response back, and remember I said you'll get the URI to send the rest of the data to. There it is. It's the session URL, and it comes back in a location header. So you should pass this header and see where to send it to. Then you perform a put to that URI containing the rest of the data. Okay, and that data should be of the correct content type. You set a special content range header that tells how much you're sending. In the successful situation, you'll get a 201 response back, and that's all you need to do. In the situation of failure, remember I said you can query the API to find out how much you've already uploaded. Well, here's how. You send a put request, which is an empty body, but has this header content range that is just slash. That means how much have I uploaded? And we'll return the 308 response back with a range of how many bytes. So we can see that when we restart this upload, we start from the 524,288th byte, and we continue to send the rest of the data. Okay? So really good. These days, a lot of applications are on mobile platforms, and really people have to pay for this bandwidth. So we'll talk about these efficiency measures later, but really just remember, this is one of those ways where you can save bandwidth. You can save uploading the same file twice. Of course, as I said, you can just use our client libraries, and this is the Java example of how to perform that. So I won't walk through it because it's simple Java, but you can see it's just a few lines, and that makes it very, very easy. Resumable upload is the default mechanism for the Java library. So without knowing it, you would use this, the best method. So that's how to get your files up into Drive, up in your Drive. And to get them out and to show you all the other beautiful features of the API, I'm going to hand over to Ivan.
Great. Thanks, Ali. Hey, everyone. I'm Ivan Lee. I'm a member of the Drive SDK team here at Google. And now that Ali's shown us how to get all these files into your drive, I'd like to show you some of the compelling operations that you can perform on these drives. So for example, here, obviously you're going to probably want to get your photos back out of your photo album. So you're going to want to be able to download it. In that case, all you have to do is take the download URL that's available in the metadata for a file and perform a get on that download URL. So you perform the get, provide the authorization headers just as you did with all the other requests so that we know what scope you have, and you'll get the binary data just as you'd expect. Just as Ali had talked about performing a resumable upload, we do honor the content range headers so that if you want to effectively perform a resumable download, you can just specify those bytes that you want. This is great in terms of if you'd like to chunk up the download, so if you'd like to if you're on a spotty connection and you want to resume from where you were before, or if you want to actually download different parts of the file in parallel at the same time and reassemble them on your side. So here, for example, we specify the content range header from the 512 12 kilobytes to 1 megabyte range, and you'll just get that chunk back. Those bytes in the content range header are inclusive. We also give our users the ability to restrict download for a file. So what this will do is it'll allow the user to control who can download this file. So anybody that is a reader for a file and they don't have write or owner permissions, they won't be able to download it. So in this response here, you can see that the file has been marked as restricted, and whoever made this request does not have edit permissions. In this case, the download URL does not show up, and they can't perform a download. Even if they did have a download URL from before, and maybe the users marked it as restricted since then, the download URL will stop working. So we also talked about converting a file into a Google document. So this will give you all that collaborative goodness that we provide. And in order to actually get that file back out of Drive, we need to export it. The original binary file has changed, so we have all these various forms of exporting a file. So for example, here, a Google document can be exported into an HTML file or a PDF, and there's 4 or 5 other methods formats that we support. In which case, you just need to select the MIME type that you'd like to export to, and take the link that's associated with that MIME type, perform a get on it using the authorization headers as you did with the download, and you'll just get the binary data as you'd expect. Now, this really closes the loop in terms of uploading a file, converting it into a Google document, being able to collaborate, share, view, all that good stuff, and then be able to export it into a more common format that maybe some other applications might be more familiar with. Not only are these desktop applications, but these can actually be cloud applications. So if you had seen our talk, one of the talks before, we had mentioned how you can actually perform an open with a Google document in the Drive, and your app will actually be able to perform an operation on that file, since you'll actually export it as a read-only snapshot. So for example, if HelloFax wanted to fax a file, it would just have to say that open this document as a PDF, and it would just be able to use that PDF as if it were a regular binary file. So now you've been able to download your file, and maybe you want to make some touch-ups to it. Maybe you want to do some red-eye reduction or put mustaches on everybody. Then you can do that with your app, but now we have to get it back into your Drive so that everybody else can see those changes. You actually have 2 options when you do this. You can actually completely replace the file, or you can actually update it but create a revision at the same time. By creating a revision, you actually get to see the history of all the changes you've made along the way. And users will probably appreciate being able to take those snapshots as you add those revisions. So to choose the behavior that you'd like to exhibit, all you have to do is specify this new revision query parameter. So in this case, we've said new revision equals true, and when you update it, you'll get a new revision for that file. You'll be able to list those revisions in the actual web UI that we have. And not only that, but we have a revisions collection, so you'll be able to perform that listing. You'll be able to delete, update, download specific revisions, and be able to get all that history. Now, we also, if you saw one of the other talks, we really encourage auto-saving files for your users. The majority of users expect cloud apps nowadays to perform the auto-saving. It almost feels antiquated to have to actually perform a save. Now, when you do this, if you create a new revision every time, that's great. That provides a lot of flexibility to your users, lets them undo operations and maybe roll back. However, this can get expensive in terms of storage. So from time to time, we actually perform a little bit of a cleanup. We delete older revisions, or maybe if there's a certain file that has had an excessive number of revisions, we'll start kind of cleaning up those earlier ones and leave the more recent ones. If you're uploading a revision that's, it's important, maybe it's a milestone, or the user said, hey, really, really hold on to this revision, you can actually mark it as pinned. This way, it won't actually be subject to that automatic cleanup, and it'll always be available for your users. They'll still have the same properties in terms of being able to delete and update and download those revisions. Do note that pinning a revision will actually count against your user's quota, just because we can never delete it. So do be wary of that. Make sure that it is a valuable thing that you would like to provide for your users. So let's say you want to make a copy of a photo, and you want to run a red filter, and then a blue filter, and a green filter, and have these various copies. Well, with our new move to this new API architecture, we're actually able to provide you with custom endpoints. So we can take a lot of the pain points away from the developer and perform them on the server side. This was a common complaint that we had with our previous API was being able to perform a copy, especially for binary files. So what we've done here is we've actually provided you with a copy endpoint. So you can copy a binary file, specify the metadata. In this case, we've specified that the title is fancier photo. And you can specify all the other metadata that you would on a normal upload. In that case, it will actually take that binary file, create a copy of it. You don't have to download and re-upload. You don't have to waste all that bandwidth, not only for us, but for you and your users. You might be curious, OK, I can specify the metadata. Can I also specify some query parameters? And of course, yes. So just as you were able to say, convert this into a Google document, or perform OCR, or perform a translation, you can do that exact same thing on a copy. It's just like an upload. And it really lets you take away a lot of the processing power that you would normally have to do in your server or your application. And we can do it on our servers since we already have the bytes. So maybe there are some photos that went into your album that shouldn't quite make the final cut, in which case we actually provide a couple of different ways to remove that photo. The safer operation is to perform a trash. So what this will do is actually move the file into the user's trash. It'll be fully recoverable. All they have to do is untrash it. This is great because it actually delegates the responsibility for permanently deleting a user's file to the actual user, so they have a little more ownership of it. And the only difference that shows up here is in the description of or in the metadata for the file that comes back, it will be that this trash bit is set to true. However, there are situations where you might want to actually delete the file. You don't want it to go in the trash. So for example, if your application maybe creates some temporary files to kind of keep track of how far it is along a whole bunch of processing. In that case, that would be a great situation where you wouldn't want to have to pollute your user's trash with a whole bunch of files that they never even created or even know what they are. So in that case, we just have this delete endpoint on the file itself, just the regular HTTP delete method. And that'll just skip the trash as you'd expect. Now that we have files in your drive, you've cleaned up all the old ones that you don't want anymore, you'd like to kind of organize them. Maybe organize them by event, or by date, or by friend groups, or even all three, since we support multi-inclusion. In that case, we just have the children's collection, in which case you perform operations on the actual folder itself, and in the body you just specify various IDs for the children that you would, or for the files that you would like to put in that folder. Conversely, we also have a parents collection, so if you'd like to add a parent to a certain file, then you can do that multiple times and just always be working on that individual file. Since we'd like you to make as few requests as possible, just because for both sides would like to do that. In that case, we allow you to specify the IDs of the parents in the actual metadata when you upload a file, as Ali had described before. The great thing about this is you can specify multiple parents here, which was another common pain point with our previous API. So here, if you specify 10 folders, normally before you'd have to actually perform 10 different requests. Here you can just perform one request, and we'll add them to all the folders for you. So now that these photos are just sitting in your drive, they're pretty boring there. I mean, one of the greatest features of Google Drive is the ability to share. And not only just share with one or two users, there's various different types of audiences that you can share it with. So for example, if I have this picture of me working hard on the beach in Australia, and I want to show it off to Ali, who's apparently stuck on an escalator, I can just share it directly with him as the user. If I'd like to share it with this group of people that dress up as silhouettes, I can share it with a group. If I want to show off to my coworkers and say, hey, I'm not really working, but you guys are, then I can share it with a domain. Or if I just want to completely make it public, since this is such a gorgeous photo, then I can just set it to anyone. Now to actually perform this, to actually add this permission, all you have to do is specify a few different pieces of data. So here you can specify the type, just as I discussed in the last slide. The role is the familiar role that you see in our UI, either reader, writer, or owner. So, and reader isn't able to actually edit the file. Writer can edit the file, and owner can actually delete the file. Owner, you might want to specify owner for a file that you might want to specify owner in a case where you'd like to transfer ownership. So, for example, maybe somebody's retiring from the company and you would like to transfer their documents from them to somebody else that's in the company so you don't lose that information. That'd be a valid case where you'd like to specify an owner. And for value, you just specify either the email address for the user of the group or the domain, such as google.com in the example I showed before. The main thing that I wanted to highlight on this slide was that the ID you get back is actually a key that we generate. A big thing that we wanted to address was we wanted to provide better privacy for our users. So just because somebody shared something with me doesn't mean everybody else that is on the permissions for that file should be able to know what my email address is. We really wanted to support a better privacy model for our users. So the key that you get back will just be a kind of a generated key. You use that to perform various operations with that permission from now on. We realize that it might be convenient to be able to use the email address just because maybe it's just a little more human readable. We provide some convenience methods such as being able to specify the current user, exposing what this generated key would be for a user in our about collection, and so on. So I guess a couple years ago, well, I get more than that, a couple guys started a search company, and that became Google. And we thought that it would be very valuable to include search with our API. So to perform search, all you need to do is specify the query parameter, Q, which is, and we have a special query language here, such as being able to search for any file where the title contains birthday. Notice that the string is in single quotes. And this isn't the only query that we support. So for example, you can search for exact title queries, so anything that exactly matches anniversary of 2012. You can search for various labels, so for example, starred or trashed. You can search for time ranges, modified time. We also support last viewed time. Full text is probably probably one of the most powerful values that you can search on, because that not only brings in the title and the description, it actually uses that indexable text that we had seen before in the example where Ali had uploaded that photo from the three sisters. We also provide searching by various levels of permissions. So if I knew that John Smith was shared as a writer on a file, then I can perform that search just like that. We also support owners and readers. And also being able to search by MIME type. Maybe your application only works on a certain type of MIME type, and that's the only one that you care about. Then you can just, in this case, search for PDFs. And also keep in mind that this list continues to grow. We always try to support more and more fields. So we actually have an entire page on our documentation that talks about searching. So I'd highly recommend checking back there from time to time in case we do start supporting other fields. So finally, we also, a very common use case is that people want to see what's been going on, what kind of activity do I have in our example, the photo album. So maybe has somebody uploaded something new to the shared folder that we've created, or has somebody started editing some of these photos. Since this is such a common use case, we'd kind of like to step through probably the best practice in terms of syncing these changes to a photo album or whatever you're monitoring. So in this case, all you see here is we have 4 files. They each have a change ID associated with them. We haven't synced anything yet. Maybe the users just installed their application, your application, in which case we haven't synced anything. Keep in mind here that 9 is our largest change ID, and we're just about to start syncing. So now we actually sync those files, perform maybe a list on the files collection. You can use a query in case you're only interested in a certain subset of those files. Once you do that, the next time, once you do that, you'll be waiting for any changes that might be happening. You'll probably be polling every couple minutes or so. In the meantime, maybe somebody's been updating your files or deleting some of these photos, in which case these changes will start to accumulate. Now, the next time you want to see what's changed since the last time you checked, all you have to do is start from change ID 10, and you'll see everything that's changed since then, rather than having to sync the entire drive over and over and perform the diffs yourself. So how does it look with our API? Well, we have this about collection, which provides a whole bunch of different information to you about the user. So for example, there's quote information, display name, profile URL. But what we're concerned with here is the largest change ID, in which case largest change ID is 9. We store that somewhere to just keep track of where we are as in a snapshot in time. We go ahead and sync the files using the files collection, just as we talked about before. And now when we want to see, OK, what's changed since the last time I took a snapshot, all we have to do is hit the changes collection and specify the start change ID to be 10. You'll notice in the response that each change has an ID number. So in this case, it's the first one is 10. And this will be a monotonically increasing number, so you can kind of keep track of the changes as they go. We also specify the file ID that the change is associated with. So if you create a new file, updated, deleted, that's what that file ID points to. Now, there's also this deleted flag. So if you were to have deleted this file, that's what that flag tells you. In this case, we see that deleted is false. So this is maybe just either a create or an update, in which case we specify the file metadata just as you would expect if you were to hit the files collection. This kind of saves you a round trip, so you don't have to get the file ID and then just turn right back around and ask us for it. However, if deleted was true, that means that the file has been completely deleted from the user's drive, not just moved to the trash, in which case we don't have any information about that metadata, so we can't actually provide you with that information, so that file field will actually not be there in the response. So those are just a few of the operations that you can do with our API. There's actually a few more that we couldn't touch on because of time, but we thought it'd be most valuable if Ali kind of talked about some best practices that you can use when using our API. So Ali?
Thanks, Ivan. So as Ivan said, that's not the whole API, but bits of it, and you can pick and choose the parts that you want. I just want to talk about a couple of best practices. We'll go into them in some detail. On how we would prefer you use the API. It's good for us and it's good for you, but overall it's good for the user if you do these. The first one is what to do in case of failure when you make calls. Now, the main cause for that will be you're making API calls too quickly. We have a few layers of denial of service protection, so we don't want you to get stuck by this. If you do make requests too quickly, what we return to you is a 403 response. Okay? That just means rate limit exceeded. And what should you in that circumstance? Well, you should do exponential backoff. So you should wait for a second and then try again. And if you still get the 403 response again, you should wait for 2 seconds, double the interval, and try again. Of course, we recommend you add a little jitter to stop you making bursts of requests all at the same time. That won't help anything. So keep increasing the time, and eventually you'll get to a point where you've hit the nice equilibrium and you can get your responses back. If, of course, you're using this and you're still hitting an absolute quota ceiling, that's when you need to get in touch with us. We're keen that developers, if they're doing it in the right way, have as much quota as they need to perform their application, obviously within reason, but we're keen for that. So we'll check it out, make sure you're doing everything right, and if you are hitting that ceiling, then get back in touch with us. So that's what to do in the case of retrying. Exponential backoff, and it really will help your applications. The other side of this, and we've touched upon it, is making sure that you treat the user's bandwidth as sacred. Really, I've said here, every byte is sacred. Some of you may get the reference. But there are a few ways that you can do this. Just reduce the amount of data you're using. On a mobile platform, people have to pay for this. And really, you don't want to be the cause of costing them bandwidth and costing them money. So the first two, fields and patch, are ways in which you can reduce either the request you're sending or the response you're getting back. Fields is a query parameter that you specify that tells the API that you only want a certain subset of fields to be returned. Okay, so you're only interested in the title. You don't care what the description is, what the MIME type is, what the links are, any of those other things. So you just ask for the title field, and that's all you'll get back. So immediately you've returned a quarter of the response or a tenth of the response that you would have done before. The converse of that is the patch operation. Now, when you do a put, when you do an update, you can send all the data. But if you'd like to just send the title, or a really useful case, just send one of those binary labels that Ivan mentioned, you just want to send the starred label, this is how you can do that. You send a patch request, and that frees you up from sending all the other data, and only the field you send will be updated. So patch and fields, send what you need, receive what you need, send no more. Now the other two, well, Resumable Upload we've spoken about. Okay? Use Resumable Upload. It helps in the case of failure, but why does that help your user's bandwidth? Well, it ensures that you never upload the same byte twice. Every byte is sacred. Never upload the same byte twice. Start off exactly from where you left off and continue. Fortunately, Resumable Upload is the default upload mechanism in most of the libraries, so you would just be using that without knowing. So that's really great. And lastly, as Ivan's just mentioned, the changes feed. There's no need to get a whole list of all the files, download them all, see which ones have changed, get the metadata, see if the titles change. We can return that feed for you. And as long as you poll that sensibly, then that will save you, again, making a whole number of requests, save you downloading files when you just don't need to. So those 4 simple best practices to save your users' bandwidth, they will appreciate you for it. We will appreciate you for it because they will be happy. So those are our best practices, and I'd like to just focus a bit on where we're going with this API. We started to tell you that this API replaces the Documents List API. Well, of course, it's not just a static thing. We're always looking at improving our APIs, and especially this one. Here's a list of features that we're looking to improve. The first one is a way for your application to store its custom metadata against our files in Google Drive. That's a very, very requested feature, and it's pretty cool. Imagine if you have your own ID for the file in your database, you just store it in Google Drive, and then you can access and get that later. So you can just tag any arbitrary data you want onto your file. That will be really useful. Batching, that's something that the Documents List API has. You put a number of requests together in a single request. You send that to the API. The Drive API will be responsible for splitting each of those requests up into their individual operations, performing each of those operations, and then aggregating the results and sending them back to you. So this, if you had to make 100 requests, all very similar, you could just send them as a single batch request, and that will save a huge amount of network for you. When you upload media files to Google Drive, we know a certain amount about them. Obviously, images have EXIF data, movies have other kind of data, transcoding and subtitles, these kind of things. And we do all of that. So we're trying to get better at exposing these things for you. That would really help our photo album application because you'd have all the EXIF data and you wouldn't have to do any of that processing yourself. Really useful. The other 2 features I've got there, the first one is push notifications. Now, we've recommended you use the changes feed. Of course, that's great, but why poll in a situation where you're going to get a push notification? Obviously, this will be different for different platforms, but every time a change happens, we will send a notification to your application, whether it be a web server, whether it be a mobile device, whether it be a client application on a desktop. They use different mechanisms, but there will be a way that we can send a notification to your application to say something's changed. So no longer will you have to be doing repeated polling. Again, this will save a huge amount of data. And finally is our collaboration engine. One of my favorite features about Google Docs and Google Drive is that more than one person can use the file at the same time. I mean, it's incredible. You've seen it. You've used it. 5 people, 10 people can use it at the same time. You see all the cursors. You see all what everyone's writing at the same time. This will no longer be limited to our applications. This is a JavaScript library that you will be able to put in your applications to provide this amazing collaborative functionality. We had a talk on this by Josh and John called Launching the New Google Drive SDK, and they actually have a demo of this, and if you can check that video out on YouTube, it's pretty cool, we think. So those are our future features. So these are in the immediate future. You know we're busy, but the important thing here is that we are guided by you. okay? So we want to know what features you want in the API, and we will implement them, okay? You're thinking, wow, what a nice guy. It's not because I'm a nice guy. The people we care about most are the users of Google Drive, okay? Your applications enhance their experience, improve their experience. Your excellent applications enhance their experience a lot, you know? And so if you can make them happy, if you can improve their experience in Google Drive, then that makes us extremely happy, makes everyone happy. So that's why we love you, that's why we love developers, and that's why we really care what you think. So star those issues. Send me an email telling me we have to have this feature, we have to have this feature. Send us an email saying, wow, you're so great. But really get in touch with us. Tell us what you need, and we will be guided by you. Happy user, happy developer, happy Google. Thank you very much for listening.